Hi everyone, welcome to Python Osmosis, episode 34, the screencast that sometimes catches errors and raises exceptions. I'm Ryan Shea, and in this episode we'll be talking about errors and exceptions. So far you've probably seen a few syntax errors as you've been playing around with Python. You've seen tracebacks and things like this. In Python there's two distinct types of errors that you're going to see. You're going to see syntax errors and you're going to see exceptions. So let's do the former here. While true, print hello world, an infinite loop to print hello world. But it didn't work as expected. Something was wrong, and we see that a syntax error, invalid syntax, is raised. And you see this little arrow here. It's pointing at the line. It says line 1 at print. There was a problem. Well, normally Python is telling you at the first place where it saw the error. So it saw it at the print statement. And the reason it saw this is because we're actually missing a colon here. So for our while true, we would need to have while true colon print hello world, and that will continue forever. So that's a syntax error, and you'll see those from time to time. Take a look at the line that's reported and go back, and hopefully you can figure out what actually happened. Exceptions are a little bit different. So let's take a look. 10 times 1 divided by 0. You can probably guess what's going to happen here. You can't divide 1 by 0, so we get a 0 division error. So there's nothing wrong with our syntax. Syntactically this is a-okay, but you can't divide by 0. It's just nonsense, integer division, or modulo by 0. So we can see exactly what the problem was there. Another example would be 4 plus spam times 3. Name error. So this means that we told it to add to 4 the variable spam and multiply that times 3. Well, there is no variable spam, so we get a name error back, and it says that spam is not defined. So that's a pretty useful error. We know exactly what's going on. Another would be if we tried to take two different types, so 2 plus 2. This would be something that would be just fine in Perl, but isn't so fine in a strongly typed language. So it tells us type error, cannot concatenate, stir, and int objects. So these are all very useful error messages. But instead of in other languages where you actually have to write conditions in order to deal with all of these, Python provides a way of handling those exceptions or catching those exceptions. So this is very useful. So these that we've seen here, they're actually classes and they're built in. The type error, the syntax error, the 0 division error, these are all built right in. So we're going to talk about handling exceptions now. So let's make a loop. All true. Try. Okay. Python has a way of catching exceptions with what's called a try and except loop. So we'll do try x equals int raw input. Please enter a number. Okay, so it's going to ask the user for a number on standard in. That's going to be sent to the int function, and it's going to be converted to an integer. But if I type something like foo on standard in and I tried to run the int function on that, I would raise a value error. So what this is going to continue on, and it's going to break out of this infinite loop once I've correctly entered in a number. Now to catch that error, value error, if somebody typed in foo on the command line on standard in, then you create an except clause, except value error, print, and then you can do whatever you'd like in here. Oops, that was not a valid number. Try again. Okay, so now we've completed our entering our while loop, and we see standard in, please enter a number, foo. Oops, that was not a valid number, try again, bar, that was not a valid number, 10. And now it broke out of the loop. So it did exactly what we wanted. Now normally when a value error is raised, it would exit the program and you'd see that exception raised, but since we handled it, we could deal with it. We could say, okay, just continue to ask the user until we got the input we were looking for, rather than just barfing. So that is the try statement. Now, you can handle more than one type of error. So for example, in this case we just said except value error, but we could have said except, and we could have done a parenthetical runtime error, type error, name error, okay? And this would have handled all of those in one except clause. You can also have multiple except clauses. So in this case I just had except value error. I could have had except value error, and then I could have had except zero division, what's it called? Yeah, zero division error. So if in my try statement I had take that input, and then after I divided 10 by whatever the number was that the person entered. So then there's two different cases of failure. The person input a number that was not a number at all, foo, as we showed, or when we go to do our division, then you can't divide by 0, so it could raise a zero division error. So then we could have except value error, and then underneath it except zero division error, and continue on with our loop until a number was entered that wasn't 0. So that's very useful. So let's take a look at another example here. I'm going to import sys. We're going to open this file for reading. We're going to read one line and set it to S. And we're going to take an integer of the stripped version of that string. And then we'll handle the exceptions, just like I was talking about, separately. So let's take a look at this. An exception for IO error, and then we'll have an exception for value error, and then we'll have another exception that doesn't specify any error type at all. Okay. So what's interesting about this is the first exception. Let's say myfile.txt doesn't exist. What's going to be caught is IO error, and you're going to get an error number and a stir error. So now we can print out IO error, and this is just a formatted print, 0:1.format, error number, string error. Now in this case, myfile.txt doesn't exist, so let's take a look. IO error, we got the error number to no such file or directory. We took what was sent on that IO error and captured that as stir error and raised that right out in what we printed. So pretty useful. The value error would be if there was a variable that didn't exist, could not convert data to an integer. So if up here we had s.strip, and so we read the first line from myfile.txt, and we tried to convert that to an integer with int here. If it wasn't convertible, if it was foo on the line, then it would have raised this value error. And then this final except, notice I didn't have any error type, so this is going to catch all of the unexpected types of errors that I didn't think of in here. And what this is going to do is print unexpected error, and it's going to print out sys.exec info. It's basically going to print out the error, and then it's going to re-raise the exception. So let's take a look at another example. So in our try clause here, we're going to actually manually raise an exception. So this is a class exception, and we're going to raise it, and we're going to pass into that exception spam and eggs, this tuple. So we're then going to catch that exception, and we're going to take what was sent into the exception as inst. This is actually an instance of the exception class in exceptions. So let me keep going here, and it'll become more clear. Okay, and this is going to hopefully make these things more clear. Print, oops. Okay, so what we have is we're manually raising the exception, spam and eggs. We're catching that exception, and we're capturing the instance of that exception so that we can get this tuple out of it. We're going to see that inst is a type of exception, and we're going to manually pull out the args by reaching in and getting those class attributes. Okay, so we see type exceptions.exception. So we grabbed the exception type with inst here. Spam eggs, when we print it out, so basically stir, as we talked about with stir and repr, stir of that instance gave us back this tuple. And if we do print on it, on inst.args, if we take the actual attributes inst.args of that class instance, then we see it's the same thing. It's actually recommended that you just sort of treat this like an object. Don't specifically go after the args attributes of this instance. Just print it, and the fact that it has a stir representation will handle it correctly. And as you see right here, print inst, it does. It prints just as you'd expect. Now you can unpack this because basically there's a __ get item method to this class, and the get item will allow you to do things like unpacking. So x, y equals inst, it just explodes that out into those two different variables. And then we see, yeah, we can handle these separately. X equals, what was x, what was y, spam, eggs. So let's take a look at a zero division error. What this is going to illustrate is that the exception is raised not just within the specific try, but also anything that is called within the try. So I create a definition just called this fails. So obviously we see that 1 divided by 0 is always going to raise a zero division error. So let's make a try. We're going to call this fails. Except zero division error as detail. Again, we're going to take that exception that's raised and we're going to capture it in detail, the instance of that exception. and then print and again stir representation of that exception is going to be printed right here in our print statement. And you see, we tried to call this fails, even though the failure happened within a called definition. It was still within the try loop because it was subsequent to the try loop, and we see that yes, it did raise a zero division error. We caught the zero division error, we grabbed the details out of it, and we printed. And you see the details: integer division or modulo by 0. That's all for now. The screencast is directly inspired by the official Python tutorial by Guido van Rossum at python.org.